This won't take long. Engine performance 2, test 4.
Can't find it.
What?
Another time.
All right, everybody brought a pen today, right? Okay. You didn't, you should have. What is global generic OBD2? Global generic OBD2. Is it the same for all numbers and models of vehicles? Format originally designed for engineers? Standardized format that meets Society of American Engineers Standard J 1962? All of the above.
Mode, $6.
Mode 6. Mode 6 can be used to verify a repair by checking what? Imagine yourself having access to a table that's stored in a computer that will give you the parameters that every particular thing is going to be looking at and what it's expected to stay within. In other words, it doesn't want it to go outside of this parameter on one side or the other, right? And so you can see the ones that are close to failing. You can see the ones that are have failed but haven't stored a code yet. There's all kinds of cool stuff you can get out of mode 6. And that's mode 6 is basically available on your higher end scan tools, where you can go in there and you look at a whole table. Now, I will tell you this, it's a sort of screwy because over on the left side where your different parameters and all that are, it'll be in this funky code, and you kind of got to know how to how to do that. That Ease Diagnostics wireless vehicle interface is pretty slick about putting that up there. But that's basically, that's going to be at the component system test passed, and there's the World Wide Web right there. Okay, mode 6 is the mode that checks which of these systems. It's going to be A, actually, believe it or not, non-continuously monitored systems. Now, what's the difference between a continuously monitored system and a non-continuously monitored system? Anybody know?
Is that, I'm just going to go for it, but is that where some of the command codes are stored?
Mm-hmm. Well, I'm talking about the system. You're not really, what you're talking about is which systems are monitored. What is a system on the car as far as part of your emissions, because this is all emissions related in this particular test. Okay, you got a whole bunch of different emission systems. You got your evap system, you got your PCV system, you got your catalyst, you got your fuel system monitor and all that kind of stuff. Now, some of those are not monitored all the time because you can't get good data about whether it's working right or not all the time. Okay, one continuously monitored component is if it's looking at throttle position sensor, engine coolant sensor, all of those kinds. They're watching them all the time because they're supposed to stay within a certain range all the time. It cannot check the catalyst without certain conditions being met, so it's not monitoring that all the time. It cannot check the evaporative system without certain conditions being met. One of the conditions for the evaporative system test, that's when it's checking to see if it can hold pressure. If you're losing vapor pressure, it can only check it if it's between 15 and 85% fuel fill. If you got somebody like my wife that always fills up her vehicle whenever it's between 3/4 and a full, she don't never let it get below 3/4 of a tank. And hers probably might have never checked its evaporative system. Or if you got somebody that runs down empty all the time. See if you ever see anybody that runs dead on empty all the time, don't ever put any gas in there, they won't ever check theirs. And so remember that. You might find somebody that puts some gas in there for the first time in a long time, and all of a sudden, boom, they get an evaporative code. It could have been there for a long time, and it wouldn't check it. But anyway, the long and short of it is, continuous monitor. The systems that are continuously monitored are the ones that are only, like EGR is only monitored while you're cruising down the road. See, you can't monitor EGR really effectively. It cannot tell you when you're sitting there idling if EGR is flowing or not. It can tell you it'll know if it's flowing, but if it's not flowing and can't flow, there's no way it can tell unless it gets up there where it's trying to use it, and that's off idle warm engine. Anyway, the long and short of it is, mode 6 is the mode that checks for, that's A, basically, non-continuously monitored systems.
Rich, I got a question. It's kind of off topic, though. It is on topic. Why is there a $sign there if it's just mode 6?
That's part of the computer code. I mean, that's what I'm telling you. That's the way they type that. It's like hexadecimal code or whatever, and they put a $sign. You'll sometimes see that in the computer code. You haven't never done a lot of computer programming, have you?
No.
All right then.
I have.
I've done some, but it's annoying. If you got to be a weirdo to want to do that for a living, you know.
Oh, yeah.
But anyway, 4, the hexadecimal number for 12 is
B.
what?
C.
B, actually. B.
C.
That's $C.
That's what I meant, $C.
Yeah.
I said
Yeah.
B, it's C.
Yeah. $C.
$C.
Yeah, B is what it is. 'Cause that's number 4. Okay. Now then, Technician A says that by looking at mode 6 data, the technician can determine how close a component or system came to passing the onboard test. Technician B says the data shown may have to be converted to obtain values that are meaningful to the technician. That's B, actually. You got it? Number 6, the data display usually shows what information? Anybody read that? We got upper limit and lower limit. Upper limit or lower limit. Test results are both B and C. In other words, upper limit meaning it's really close. You know, you've seen sometimes you'll pull a code that'll say that it's reached its lean adaptive limit, or at least its rich adaptive limit. And one time we were working on this Jeep, or I went over there to piddle around when Donnie was still working at the Ford place, and I said, "What are you doing to this Jeep?" He said, "I got a code that's, you know, throwing me in the direction of an oxygen sensor because I don't find any air leaks or anything, and you know the fuel trims are way off and all that." So he put the fuel trims were like plus, you know, which means it's adding fuel to correct for a lean condition. But if the oxygen sensor goes into a flatline situation, then you'll have one that's correcting toward the rich side. So it was really easy to grab an oxygen sensor and just screw it in there. Well, he did that, cleared his code. We drove it down the road and it was just like it was. It doesn't change. When we're looking at the data stream, I noticed that the barometric pressure was reading really high altitude. You know, it's like reading 3,500 feet or something like that. And here we are at 250 or 400 feet above sea level. And I said, your map sensor is bad. It's reading high altitude, and that's causing. What happens when it reads high altitude? It doesn't put as much fuel in there because there's not as much air. If it doesn't put as much fuel in there, the oxygen sensor picks up a lean condition. The computer says, "My goodness, we're lean." Now we got an in-range failure. So it doesn't know them. It doesn't know that it can't trust the barometric pressure sensor because it's an in-range failure. Anytime you got an in-range failure, it's not going to throw you a code that's going to point you to what you're doing. Like a perfect example was Katie's Mariner. We pulled a PO128 code which told us the thermostat was stuck open, but it turned out our engine coolant temperature sensor was reading. It was in range. It wasn't shorted or open, but it was reading 60 degrees colder than what was true. See what I'm saying? So it didn't throw us an engine coolant sensor code because it didn't know that it couldn't trust that sensor. So if it's in range, it won't know it can't trust the sensor, and it'll throw you a code that's being created by that particular in-range failure. Another example of that, we're driving this Pontiac Aztec that belonged with the instructor from the other campus. We head off up the road. This thing would go about 50 miles an hour, and that's all you could get out of it. And all that. But I noticed that I'm looking at the scan tool here, and when I get up, it's pretty well normally, acceleration normally up to about 50, and then you're just sort of hunkered down and you're not picking up no more speed. But I noticed I was watching the mass airflow, that no matter what I did, it didn't seem like the mass airflow could read above a certain reading. So I said, let me go out here and force this mass airflow, you know, unplug it. Because they switch it off, unplug the mass airflow. When you crank it up, if it sees something it knows is not reliable from the mass airflow, it's going to pick other things to use. It's going to use the throttle position, and you know it's got a map sensor on it too, and all that on that year model. And so after with that mass airflow sensor unplugged, it ran like a racehorse, you know, and just throw you back in your seat and go on up. And so the mass airflow sensor was an in-range failure. It wasn't throwing us a code for a mass airflow sensor. We had to figure it out. See what I mean? There's not any kind of a machine except for one in your head that's going to come up with the answers, right? All right, so let me see. But see, upper and lower limit. If you'll see someone will say upper adaptive limit reach, you know, it's going to tell you that it's got as high as it can go trying to fix a problem that's there, and you got to figure out what's causing the problem it's trying to fix, basically. That's why we got to think beyond pulling a code and replacing a part. So you don't plug it in, pull a code, replace a part. That's wonderful if you can get away with that, but you know, not that way most of the time.
So is it B or D on that?
That's on number 5, isn't it? No, 6, I'm sorry. 6 is basically D there, both B and C. The oxygen sensor switch from time from rich to lean is identified as test identification Test identification TID what? See, that's what you're going to see in your mode 6 data field over there. Number 7, that's something you can't guess your way through, right? That's going to be TID $05, basically. That's going to be A. All right. Type A misfire codes are those that can damage a catalytic converter and usually have misfires that range from what at idle to what at high engine speeds. Number 8, that's going to be 40% to 4%. A General Motors vehicle is being checked using mode 6 for the proper operation of the oxygen sensor. Rich to lean sensor time switch is, how many seconds is that? 0.030. Is that, what is that? Is that 3/10 of a second? Or 30/100 of a second? They're both the same, aren't they? All right, in one way or another, technician A says this indicates a slow reacting oxygen sensor. That don't sound slow to me. Technician B says the oxygen sensor is reacting correctly and is okay. That's B. If it's going up and down really fast, I mean, you want to see this thing going up and down, except you have to do it with a marker that will write, that somebody hasn't left the doggone cap off of. I mean, it's got to be going up and down real quick. And if it's just lazy and it's moving around and it's not, if I see one that's lazy, I'm going to crack the throttle a little bit and bring the speed up so that there's a, gas flowing past it and all. And I want to see it start switching really, really quick. And basically, it needs to switch within the whole range that it's supposed to switch within, too.
So that's only upstream?
Upstream, yeah. The downstream is going to be lazy, but basically we're talking about the one that affects it right now. I mean, affects the way it runs. The downstream is, I've never seen a downstream and affect the way it runs. It's just basically to monitor the catalyst. That's all it's there for. All right, let's flip it over. Number 10, mode 6 information can be accessed where? You can get it at nastf.org, NASTF, which is a good place to go. It doesn't cost anything to go there. You can get it at motorcraftservice.com. You can get it at service.gm.com, and here are all those. Number 11, the hexadecimal number for 6 is D, $6. See, it's not always the same. What was really interesting is we used to have some Jeep Cherokees, Grand Cherokees, that the trip computer was reading 13 miles to the gallon when they were actually getting 18. That is a bit of a concern to a customer. They don't like that, And so what we would do is we would take the DRB2, which was a scan tool before the DRB3 came out, and we'd have to go into a particular place in the tool, do a little, dance to get into the place, and we would have this whole table full of funky numbers. They were like little 4-digit number and letter sequences, and it would tell us to go to this particular address and change these particular 2 numbers to, a certain value, like it might say 3D7H or something like that. We'd have to change it to 2D4X or something like that. And after we changed those, it would fix the fuel computer. Now, I don't know if it was actually making the computer tell the truth or if it was just lying to them, telling them they were getting better gas mileage than they were getting. But anyway, we fixed them that way. It was an actual service fix for those. And you don't usually see that kind of thing, but that was how we did those. Number 12, you got all these different modes. Mode 8 is the mode that checks which of these systems. Module identification, oxygen sensors, bidirectional control of onboard systems are all continuously monitored systems. That one there is actually going to be C. That's actually going to be C. Bidirectional control of onboard system. Now that the small scan tools that we have don't have bidirectional control. You can't turn nothing off and on with them. All you can do is read what's going on. The bigger scan tools, and like the one I carried in the trunk of my car, and the one we got in there, the Genesis tool. This one here, you can actually tell things to happen if you go into actuator test mode or special functions, and you can tell it. Some of them are really cool because if you're checking the evaporative system, you can go through an evaporative test that will close the vent, it will put some vacuum in there, and it will monitor the tank pressure, and it will put you a little field there that is supposed to stay in that range for a certain amount of time. And if it does, you're okay. If it doesn't, it's real easy after you've performed what you think is a good repair to go back and rerun this test right quick. But to get that monitor to clear, driving around town, is a pain on a lot of these. I mean, to get the evaporative monitor to clear, it's the hardest one to get to clear. I mean, drive, to get that darn thing to clear. And basically, you're supposed to, if you do it right, and a lot of people don't, but if you do it right, you'll have a little tool or a little device, you know, like you can get plugged in, that'll tell you when the monitor is all cleared. Because if you don't, you go in there and you punch in P1000 code, which means that somebody's cleared the codes or disconnected the battery or something like that. If it gets a P1000 code and you're in a state that does emissions testing, they'll send you right back out the door if they get a P1000 because they know you cleared the codes, or somebody did, you know. But anyway, let me see. An oxygen sensor maximum sensor voltage for test cycle is identified as test identification number, and this is out of your mode 6, right? That's going to be D. That's going to be $08. $08. Have you ever noticed whenever you're naming a file in your computer, like if you're naming a file that you're saving, there are some characters it won't let you use? Or have you ever noticed that? When you're naming a file, if you're trying to use something like a slash, it'll say, you can't use that. Because that's that program control instruction thing or something. If you try to, if you're trying to save a file with dollar signs on it, you know, it won't let you do that either, you know, because it'll cause issues. It's kind of funny. I had all these computers in here back when everything was running on Windows, whatever it was, 98. And when I was using my AllData, I would actually, they'd send me the disks from AllData, and I would have to store them in appropriate folders on the machines because these computers weren't hooked to the internet in here then. And so I would go into that folder and I'd say select all files, delete, yes to all, you know. And I was doing, you get to where you're doing it so fast because I was doing it on a bunch of computers. And on that computer that was sitting right there at the time, I accidentally went into the Windows folder and did that. You know, select all, delete, yes to all. And when I got through, I realized too late what I had done. I said, well, Cobb can come reload the darn thing or something. I don't care. You know, ain't a big deal. So there's a whole bunch of computers in here. But I mean, it's the kiss of death, you think. But that Windows system, even 98, was so smart that all it erased was the stuff I didn't need. And the computer booted back up, and that one ran a lot better than any of the rest of them after that because all the trash was gone. So if you want to clean your computer out, go into your Windows folder, just wipe everything out, you know, see how it does. No, that's scary, isn't it? Everybody's, you know, making your hair stand up. I did it by accident on that one, and it made it work better than any of the rest of the computers in the shop. Okay, that's a stupid story, but it was what, you know, something I did. Okay, let's see. An oxygen sensor switch time from lean to rich is identified as test of identification what? That's actually going to be C. See, there's no way you can know these off the top of your head. You're supposed to be looking them up in the book. C as $06. Which of these global OBD2 modes is used to clear and reset diagnostic trouble codes, freeze frame data, readiness status monitors for non-continuous monitoring? Thanks, appreciate that. Did he send a ticket or anything, or did he just give me these?
He didn't send one.
Oh, how sweet. Thank you.
He'll get you later.
All right, I'm sure you will. All right. All right. Which one? Let me see. I got, that's 15? Or what, is that one we're on?
Yeah.
15, that's D, that's mode 4. These global OBD modes are used to clear and reset diagnostic trouble codes. Get my tongue tangled up. Freeze frame data, readiness status monitors. Now, here's something else. Don't clear your codes until you've looked at the freeze frame data. The freeze frame data is going to tell you what was going on when the code was set, and you need to know that sometimes. How fast were they going, what the engine temperature was, how deep they were in the throttle, what the engine load was, engine coolant. Will tell you all that kind of stuff. This is where they were when it was set. It's a similar conditions window. And if you want to try to duplicate that, you need to try the best as you can. Look at that freeze frame data. Get it to about that temperature. Get it to about that load. Get it to about that road speed. See if it'll do it again for you when all those conditions are met and everything comes together. And if you're digging into some of that stuff, trying to troubleshoot, it's important to understand what all that's about. Okay. Number 16, type B misfire codes are set if the misfire exceeds what to what, depending on engine make, model, and year. That's C, 2%, 4%. And technician A says by looking at the mode 6 data, the technician can check the monitor status before starting repairs. That's smart. Technician B says you can look at the component or parameter that triggered the fault. Who's right about that? Both of them are right. And finally, see how fast this is going today? We've only been in here like 19 minutes. Is that, you all happy about that? All right. Number 18, an estimated blank of the PCM diagnostic trouble codes can be diagnosed using the global OBD2 function of the scan tool. How much, what percentage?
70.
80% actually. 80% you can do. Remember now, there's 2 rooms in that box. You got an enhanced OEM room, and then you got your OBD room. You need to look in both places. Matter of fact, it's a lot, sometimes, and I usually go into the enhanced room first just out of, curiosity or whatever. But a lot of times it's best to go in the OBD2 room first, look in there first, and then back out and go into the OEM room, but it's just up to you, whichever way you want to look. But if you don't look in both rooms, you're remiss. You need to look in both rooms. And everybody in here needs to be plugging scan tools in and looking at what normal readings look like, so you're not totally lost if you have to fix a car. You got me? All right. Yes. All right. Let me see. Technician A says non-continuous monitors include catalyst efficiency, EGR, evap, oxygen sensor monitors, oxygen sensor heater, secondary air injection, and thermostats. Technician B says mode 4 is used by service technicians to monitor PCM test results of various systems. That's only A, because mode 4 does what? What does mode 4 do? We just had a question about that, guys.
Reset diagnostic.
It clears the codes, right? Okay, Technician A says some scan tools translate the raw hexadecimal data into English using software in a PC. Technician B says the system makes the data easy to read. And that's A, Technician A. Yeah. Now on these computers that are operating these vehicle systems, it was interesting to me that the very first thing that they put computers on there to do was the most complicated thing they have to do, and that's fooling around with the engine controls and the timing and all that. But in there, you've got various different little program managers, and the foreground manager in a computer system is the one that manages the essential stuff that has to happen right now, your fuel injection and your spark timing and all the stuff that's happening immediately. The background manager is the one that handles the EGR and all of the other stuff that doesn't have to work all the time to keep the engine alive. You understand what I'm saying? So you got foreground manager and you got a background manager in there. And we got a little book about that from Ford one time. I just wanted to share that with you a little bit. Anybody got any questions or comments? All right. Everybody work hard all day. We got to get cars fixed.